Okay, Precalc, we have our quiz on Wednesday covering the first 4 sections of Chapter 4. Here are 8 problems to go along to help you study. First, angular speed. A car is moving at a rate of 65 miles per hour, and the diameter of its wheels is 2.5 feet. Find the angular speed of the wheels in radians per minute. So again, we have this car, and I'll do my best to draw a car. Right? And here's the tires, right? And as the car is moving 65 miles per hour, there is a point on this tire that is rotating 65 miles per hour. That's the linear speed. So they're giving you the linear speed, and they want you to go all the way to the angular speed. So it's just one big unit conversion, okay? So we're going to do that. Start with the rate. 65 miles per hour would be 1 hour. Now, I need to get it to radians per minute. That's what I need to get to. So the first thing I'm going to do is I'm going to convert miles to radians. Now, my diameter is in feet, so I need to convert from miles to feet. So 1 mile is 5,280 feet. And now I have successfully converted from miles to feet. Now I will bring in the fact that 1 revolution is the circumference. And I was having you remember 2 pi r, but there's another formula you can use, pi times diameter. 2.5 is the diameter. So pi times 2.5 feet, that is going to be 1 revolution. And now I've taken away the feet, and now I'm in terms of revolution. And then for angular speed, 1 rev is also 2 pi radians. And there is 1 rev is 2 pi radians. And now my top is in terms of radians. So now the bottom, I need to convert from hours to minutes. 1 hour on top is 60 minutes on bottom. Hours cancel. And now we can go ahead and multiply the tops and then divide by the bottoms. Now one thing you could do is you see pi on top and pi on bottom. You could cancel those out. That gets rid of one thing you have to multiply by. So 65 times 5,280 times 2 divided by 2.5 divided by 60. And I do these each separately. Each division I do separately. And I got 4,576. And that would be radians per minute. So that's how fast the angle is rotating around. 4,576 radians per minute. Okay. 2. It says the pointer on a voltmeter is 6 centimeters in length. Find the angle through which the pointer rotates when it moves 2.5 centimeters on the scale. And let me grab the picture real fast for you. Okay, so here's a voltmeter. A voltmeter is used to measure voltage or current. So it says the pointer is 6 centimeters long, and it says find the angle through which the pointer rotates when it moves 2.5 centimeters on the scale. So what it's saying is okay, so I'm 6 inches long. When it moves 2.5 centimeters, what is this angle that you're moving through? What's that theta? So the 2.5 centimeters is an arc length. This is an arc length problem. Arc length equals radius times theta. So S is my arc length. 2.5 equals my radius, which is 6, times theta. And we're going to divide by 6 on both sides. And we get a decimal, 0.4166. It keeps going on forever. I'm going to leave it is theta. And this is in radians. Now I want degrees. Okay, so I'm going to keep that in my calculator. So to convert this, so I'm going to take theta, which is 0.4166 radians. I'm going to multiply it by 180 degrees over pi. Because pi is in radians, and there's the radians canceling. If you put them down here, pi is in radians, the radians cancel. And now I take that number, times it by 180, and divide it by pi. And this will give me the degrees. And the degrees I get 23.87 degrees. So again, that's about roughly the angle that voltmeter moves, angle-wise, as it moves 2.5 centimeters along the arc length. Okay. 3. I'm going to write this problem down for you. It says, use identities to transform the left side to the right side. And the original problem says 1 plus cosine theta times 1 minus cosine theta equals sine squared theta. And what I suggest we do is we multiply this. Let's FOIL this, okay? So 1 times 1 is 1. 1 times negative cosine is negative cosine. Cosine times 1 is positive cosine. And cosine minus cosine, cosine times negative cosine is negative cosine squared. And this, the cosines cancel, we get 1 minus cosine squared theta. So now, how do we make this become the right side? How do we make 1 minus cosine squared theta equals sine squared theta? Well, remember your identities over here. You have these things called Pythagorean identities. Cosine squared plus sine squared equals 1. So if I were to subtract cosine squared from both sides, sine squared equals 1 minus cosine squared. And what I've done is I've transformed this Pythagorean identity into 1 minus cosine squared. 1 minus cosine squared equals sine squared. So we just do a substitution. Sorry, let me write that better. Sine squared theta equals sine squared theta. And that's what you want. You want the left side to equal the right side. Okay. Next. Use a calculator to evaluate this problem. And I threw this on there for a couple reasons. Number one, how do we do the reciprocals in the calculator? Number two, this is degrees, minutes, 8 minutes and seconds. How do we convert that? And the last thing is make sure you're in the correct angle mode. This is in degrees. So make sure your calculator is in degrees when you do this problem. Okay? So first, how do we convert the angle? Well, 56 degrees, 8 minutes and 10 seconds is going to be 56 plus 8 divided by 60 plus 10 divided by 3600. 8 divided by 60 plus 10 divided by 3600. And I got, and we can round to like 4 decimals, I got an angle of 56.1361 degrees. And that's what I'm going to find the secant of this angle. Now to find the secant of that angle, we need to think of it as the reciprocal of the cosine. 1 over the cosine of 56.1361 degrees. 1 divided by cosine of 56.1361 degrees, and I get roughly 1.7946. And there you go. So degrees, minutes, seconds, and then to do the calculator, 1 over, make sure in the correct angle mode, degree or radians. Number 5 here. You are standing 45 meters from the base of the Empire State Building. You estimate the angle of elevation to the top of the 86th floor is 82 degrees. If the total height of the building is 123 meters above, if the total height of the building is another 123 meters above the 86th floor, what is the approximate height of the building? Okay? We're not going to do the second part. We're just going to do the first part. Okay? So here's the picture. So you're standing here. Here is the Empire State Building. I think it looks something like that. Okay? And say this is the 86th floor right here. So from you to that floor, there's an angle of elevation of 82 degrees, and you're 45 meters from the building. Now they give you this extra piece of information that says that above the 86th floor, there's another 123 meters. Okay? And they want the entire height. So what is this total height? So you're going to find, in your problem, you're going to find this height. Let's call this x. You're going to find x, and then, not from there to there, sorry, from the 86th floor, from there to there. You'll find x, and then add it to 123 to get your total height. Okay, but nonetheless, here's our picture. This is the right triangle. Here's my angle. Opposite is the unknown. Adjacent is the known. So that's going to be a tangent equation. Tangent of 82 degrees equals my opposite x over my adjacent 45. I multiply both sides by 45. Make sure in degree mode, 45 tangent of 82 equals, and I get roughly, wow, 320, and I'm going to just do 320 meters. So then the total height h is 320 plus 123. 320 plus 123 is 443 meters tall. Okay? So right triangle trigonometry, making sure you know opposite, adjacent, and hypotenuse. Sine, cosine, and tangent. 6. The point is on the terminal side of an angle in standard position. Determine the exact values of the 6 trigonometric functions of the angle. Okay, so this is not the problem I wanted. Give me 1 second. Okay, that's better. I wanted that point, negative 410. So what you're going to do is you're going to first decide which quadrant this is in, and negative 410 would be in quadrant 2, so this is in Q2. So I might draw a picture, put an angle with its terminal side at negative 410. That's somewhere right up here, right? So here's my angle, and if it's negative 410, I'm going to drop this vertical down to make a right triangle. Negative 4 is the x, and 10 is the y. So we go to the left 4 and up 10. So now I need to find my hypotenuse. Let's call it z. So use Pythagorean theorem. 4 squared plus 10 squared equals z squared. That is 16 plus 100. That's 116 equals z squared. And I will take the square root, and I need to try to simplify 116. So I will try to see if there's any perfect square factors that go into 116. And I see that 4 goes into 116. 4 goes in there 29 times. 4 and 29. And 4 is 2 squared. So when I simplify z, 2 comes out of the radical because it is squared, and 29, which is the other factor I need, stays inside the radical. So 2 radical 29 is my hypotenuse. And now I'll go through and I'll find the 6 trig functions. Sine of theta is opposite 10, and it is positive, over hypotenuse 2 radical 29. 2 and 10 simplify to 5 and 1, and then I will rationalize by multiplying top and bottom by the square root of 29. And I get 5 square root of 29 over 29. Cosine of theta is going to be, now it's negative because the 4 is negative, negative 4 over 2 square root of 29. And this is going to be cancel, cancel, 1 and 2, rationalize, negative 2 radical 29 over 29. And then the tangent of theta is opposite 10 over adjacent, which is going to be negative 4. And that simplifies to negative 5/2. So I'm going to slide over here, and I'm going to do the reciprocals. So the cosecant, which goes with the sine, if I just take the reciprocal of the original fraction, 2 radical 29 over 10, the 2 and the 10 simplify, and there is no rationalization because the radical's on top now. Radical 29 over 5. The secant of theta is the reciprocal of cosine. Again, do the similar thing. Take your original fraction, negative 2 radical 29 over 4. The 2 and 4 simplify, and I get negative square root of 29 over 2. And then my cotangent of theta. Now here I'm going to look at the final answer because it's simplified. And just flip it upside down. Negative 2/5. And there's how we find the 6 trig functions from knowing which quadrant and the x and y of a point on the terminal side. 7 here. Use the function and trig identities to find the indicated value. So I'm going to write the problem down. It says cosine of alpha equals 1/3. And you're supposed to find the sine of alpha. Okay? Well, which identity involves cosine and sine? It's the Pythagorean identity. Use the Pythagorean identity, which says cosine squared plus sine squared equals 1. So cosine of alpha is 1/3. Sine squared of, we'll stick with alpha. Alright, because that's what I'm trying to find, equals 1. 1/3 squared, I would try to avoid decimals, so that's going to be 1/9 plus sine squared alpha equals 1. We will subtract 1/9 from both sides. Sine squared alpha, I can't make my alphas today. Sine squared alpha equals 1 minus 1/9 is 8/9. And then we'll take the square root. And this gives me sine of alpha equals, now we will do the square root of 8 over the square root of 9. 8 is 4 and 2. 9 is 3 squared, so it's just the perfect square of 3. And then the 4 will come out as a 2. Because 4 is 2 squared, 2 pops out. So the sine of alpha in simplified radical form, 2 comes out, the 4 is gone, still a 2 in the top, all over 3 in the bottom. And that's using the identities, the Pythagorean identity, to find a trig value from a given trig value. Okay. And then lastly here, find two solutions to this equation, and we're going to give them not in degrees, we're just going to give them in radians. So radians. So what I'm looking for is, first of all, which first quadrant angle has a sine of radical 3 over 2. So if I think about my unit circle, right, sine of radical 3 over 2 means you go up high, right, radical 3 over 2 and then 1/2. So that's your point. 1/2 radical 3 over 2. And that's going to be the 60-degree angle, or pi over 3. So you're part of the pi over 3 family. So now the question is, okay, which quadrants is sine negative? And sine is negative in quadrants 3 and 4. So my thetas have to be in quadrants 3 and 4. So the pi over 3 family is pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Third and fourth quadrants. So theta is 4 pi over 3 and 5 pi over 3. And again, you can always check to make sure that you are correct, but you are. And there is the two angles. Okay, so hopefully this review helped. Again, it's not everything. Make sure you study everything, but it is a good chunk of the quiz. All right, good luck, and we'll see you on Wednesday.